involved in the vibration analysis is a different thing. Now, basically, you understand that you take any system, any vibratory system, okay, not only schema system, any vibratory system. So, whenever you are taking any vibratory system, now basically this vibratory system is nothing but a dynamic system. It is nothing but a dynamic system because there is a vibration, there is an oscillation. Okay, so vibratory system is a dynamic system for which, and for this dynamic system, what is the input? What is the input? Excitation. Input is nothing but the excitation. Or normally you can call it as a E excitation. E excitation means what? External excitation. And what is the output for this? And output for this is nothing but the responses. Whatever you have a response, output is nothing but a response. For example, displacement or maybe a amplitude. Okay, it can be a response. So basically, for any vibratory system, which is a dynamic system, have input as external excitation and output as a responses as a displacement amplitude. So both of these are t dependent. So they comes under the time domain. Time domain means what? If you represent it on the x-axis, you will have a t. On the y-axis, you will have a response. Let us say response is c of t. This C means what? C indicates a response. Okay. So C of t is nothing but it's a time dependent. Okay. So maybe it can be a increasing oscillations, or it can be a decreasing oscillations, or it can be a oscillations with a constant amplitude. So that detail we will understand in the model number 5. Sorry, model number 4. But you understand that both the responses are the time domain, right? Okay, now basically the response, okay, now this response depends upon what? This response depends upon again the external excitation. What type of external excitation you are providing? Which you are providing a harmonic excitation, okay, if the excitation is harmonic, if the excitation is non-periodic, if the excitation is non-periodic, let us say, or if the excitation is random, okay, it is random, means what? It is not deterministic. You cannot determine the magnitude. So depending upon the excitation, you will get the response, okay. And this is the one point, and the second point is initial conditions, okay. So normally, guys, try to understand that while doing a mathematical analysis or a theoretical procedure, we are most of the time neglecting the initial conditions, okay. But practically, some initial conditions has to be considered. For example, inertia. Let us say inertia, okay. So this inertia can be also initial condition. So there are a lot of initial conditions. So based on the initial conditions or excitation, okay, you get a response, right? So this is why I'm telling you this, because before you understand the steps involved in the vibration analysis, you should understand this, okay? I hope it is clear to you. Now, basically, if you take the example of this vibratory system, okay, basically, if you take the example of this vibratory system, okay, now this system is basically a complex system. This system is basically a complex system, right? And most of the practical vibratory system, I'm writing here P, most of the practical vibratory systems are a complex system. Okay. And since it is a complex system, okay, it is impossible to to consider all the elements for the mathematical modeling. I am repeating my statement. Since a practically vibratory system is a complex system, it is very impossible to represent all the elements. But to if you are following a proper steps involved in the vibration analysis, we are trying to consider most of the elements. Means what? We will try to cover for example, if you take an example of a car is a practical system, and I say that convert this car suspension system into the mathematical model, okay, and do the vibration analysis, so that you can calculate what is the frequency, what is the natural frequency, what is the external excitation of the frequency, okay. So all parameters I can calculate. You can design the M, you can design the C, you can design the K, okay. But it is again impossible to represent all the elements. So we are following certain procedure and we are trying to incorporate each and every element. I hope it is clear to you all. Okay. So I can say that most of the time all the important features are considered in the analysis, and what we do basically we predict the behavior of the system. Okay. Basically we predict. I can write here predict the behavior of vibratory system, okay, under different input conditions, very important. For different input conditions, your system vibratory system will behave differently, okay. Now there are a lot of conditions like under damped, over damped, You can call under dam, over dam, or critically dam. So detail you will understand in model number 4. Means what we will do the mathematical analysis for all the three. Okay. But here you just understand that we are just understanding the basic steps involved in the vibration analysis. Okay. So what is the first step? Mathematical model. Okay. Now mathematical modeling means what exactly? What you are doing in this mathematical modeling? Now you might have understand that you are, let us say a car is a practical example. For this car suspension system, you are constructing a mathematical model which will have the three basic elements. MCK means what? This physical system, this car is nothing but a physical system. You are converting into the mathematical system in terms of what? MCK. Why? Because you are doing a vibration analysis, and MCK are the basic parameters or basic elements of a vibratory system. So I hope you understand uh, what exactly we will be doing in the mathematical modeling, right? So you are converting a physical system into the mathematical model. Okay. So basically, this mathematical model should be as simple as possible. You try to make it simple. You should not make it complex. Okay, because automotive car suspension system is a complex physical system. You are trying to make it simple, but your output or result will be same as that of the physical. Is it okay? Is it clear? So next is what? Derivation of the governing equations. Okay. Now I will come to the point. What is exactly a derivation of the governing systems? Okay. The third one is what? Solution of governing system, and last one is the interpretation of the result. Okay. Now before I explain you these 3 points, one, two, three, and four. Okay. Let us first of all take an example for this mathematical model. Okay. I will take one example, and then we will understand these three concepts. Okay. So the example is actual system. This actual system is nothing but a physical system. Okay. I have taken a small example from your production processes. You have studied in production processes. So what is a small example? A forging hammer. Okay. This is an example of a forging hammer. Okay. I will take an example of a forging hammer. You know what is the process of forging. Okay. Now, let us say that you have to do a mathematical model of a forging hammer. The first condition you have to understand that whether you are considering a single degree of freedom system or you are considering a multi-degree of freedom system. So depending upon the application, depending upon your criteria, depending upon the conditions, you can either mathematical model this into the single degree of freedom or multi-degree. I will explain you both. Okay. आपण दोन्ही बघणार आहोत. Okay. Now let us take an example. Now basically what is this forging hammer? This forging hammer consists of a frame, right? Then it has a falling weight, the weight which will fall. Then uh, now this basically again there is an anvil. This is nothing but the anvil. Okay, anvil means what? The weight will fall on this anvil and it will give you the desired shape. Okay, so this is nothing but an anvil, and then we have this foundation block. This is the soil. Soil means what? We are keeping it on some earth, right? Means we are grounding it. So you know that earth or mud or soil, you can consider it one and the same. Okay, is it clear? So first of all, try to understand what are the physical system. Then this is the elastic pad. So this elastic pad is used for a vibration dampening. Basically, in automobile car suspension, we are using a spring damper. So here, vibration dampening. Okay, so we have to dampen this vibration. So that is why we are using this elastic pad. So this elastic pad is one sort of damper, right? Then soil. This soil is also one sort of damper. Why it is one sort of damper? Because you know that our earth, soil or earth mud is able to damp all the things, right? So this is nothing but a basic, you can say, the system. Okay. Now basically this anvil is, you can basically this anvil you can call it as, it is nothing but a massive block, right? You might have studied this process. Anvil is a massive block on which material is forced into the desired shape. Okay, it is a block, and here let us say you have some material. Let us say this is nothing but a material. Okay, I have shown by the red material. So this is something nothing but a material. So this weight will fall on this material, and with the help of this weight, falling weight, and this anvil, or you can say a massive block, you will get a desired shape. You will get a desired shape, right? Now this desired shape, okay, desired shape means what? This weight will fall, and it's like you will have a repeated blows. Okay, you will have a repeated blows. पण त्याला रिपीटेड ब्लोज असं म्हणतो, म्हणजे त्या वेटचे त्या तुमच्या अँगल वरती आणि मटेरियल वरती रिपीटेड ब्लोज होणार and the material is forced into the desired shape. Okay, this is one more thing. Now this anvil is again mounted on the elastic pad, right? So as I said that elastic pad is used as a vibrational damping structure, or it is basically elastic pad is used to reduce transmission of vibration to the foundation. So basically this elastic pad can be called as an isolators also, right? It can also called as an isolators. Means what? This elastic pad is preventing the vibrations which are created in the system, that is the frame and all the anvil, to the foundation block. So I am preventing the vibration from this machine to the foundation. So elastic pad is nothing but the isolator. Isolator is something which is between the foundation and the machine, right? I hope it is clear to you all. So now, what is the aim? What is the aim? I have to do the mathematical model. So first of all, to do the mathematical model, let us take a basic parameter MCK and single degree of freedom system. Okay, is it clear? So first of all, guys, message me. Have you understand the process? Have you understand the process or not? First of all, message me.
Yes,
Have
sir.
you understand the process? Okay, chalo. Now we will draw a diagram. Okay, so how we draw a diagram? So first of all, let us take some mass. Okay, so first of all, let us take some mass. So what is the mass in this case? Anybody? What is the mass in this case? First of all, mass. Mass is nothing but a, let us say, frame. Okay, I'm taking a singly frame, then anvil. Okay, and let us say foundation block. Okay, now this is nothing foundation block, right? This is nothing but a foundation block. Now, guys, first of all, try to understand this mass is nothing but the equivalent mass ME, which is equal to M1 plus M2 plus M3. Why? Let us say M1 is the mass of frame, MV is the mass of M2, M3 is the mass of foundation block. So I have converted it into a single equivalent system. So I have considered the equivalent mass. Okay. Next, now let us say this is a system. Okay, this is a soil, or you can say ground. Okay, this is soil, nothing but a ground. Now, what is the? Let us say this is a. You can say this is a. You can say a falling weight. This is nothing but a falling weight. Okay. Now let us say that a damper. Okay. This is a damper and this is a K. Now what is K in this case? What is K in this case? Stiffness of K is nothing but the stiffness of elastic pad, right? Stiffness of elastic pad. Okay. And damper, what will be the damper? See, what will be the damper in this case? Anybody? What is the damper? Elastic pad. So elastic pad will work also as a
Elastic pad.
damper. Yeah, elastic pad and soil. So elastic pad and soil, I will consider the damper. Now this diagram is called as a mathematical model for the physical system. So what I have done, first of all, I have considered a mass M1. Then I have considered the C, that is elastic pad and the soil, and then stiffness K. Okay, stiffness K. And weight, falling weight, this is nothing but the F. F is nothing but the external excitation force. Okay, so whenever this weight is falling, the system is disturbed from the main position and the system started oscillating. Then this damper, you have to consider elastic pad and the soil, and stiffness, again stiffness of the elastic pad K, they will dampen the system for the foundation block. Okay, now let us say that x1 is the displacement. X1 is the displacement in downward direction, assuming that F is downward. Okay, so here only one coordinate is required to define the motion completely, and that is why this system is called as a single degree of freedom system. Now tell me, have you understand this? Have you understand this? Okay. So this is the diagram which I will explain you in the figure. So this falling weight, frame, anvil, and foundation block, damping of elastic pad and soil, stiffness of elastic pad and soil. So this is called a single degree of freedom. Now I say that you can convert this into the 2 degree of freedom system or 3 degree of freedom system. Okay. You can also convert this if you want. See, basically try to understand that as you increase the number of degrees of freedom system, accuracy increases. The accuracy of the system will increases and you will get omega n more accurate as compared to the single degree of freedom system. But again, the complexity will increase. The system will become more and more complex. The system will become more and more also costly. Okay. So if not required, don't go for the multi-degree of freedom system. If required, then and then only go for it. Otherwise, we are very happy with the single degree of freedom system because it makes the system very easy. But let me complete the process. Okay. Now see. Now this figure shows you the single degree. So how I have converted? So I have taken M1 as a mass of frame and the anvil. M1 is a mass of frame and the anvil, and I have taken M2 as a mass of the foundation block. Okay. Now let us say that x1 is the displacement of mass m1 and x2 is the displacement of mass m2. Okay. So now here two coordinates are defined required to specify the motion completely. So this system is called a two of system. Okay. And the rest is same. Now you know that frame and the anvil. Okay, frame and the anvil and the foundation block. What is the K? Stiffness of the elastic pad. What is the C? Damping of the elastic pad. Then from foundation block to the ground, what we have? Damping of the soil as a C and stiffness of the K. Means what? Here I have combined this. Here I have combined C and here I have combined K. But here, if you look into the figure, I have, see, below the foundation block, you have the soil, na? And above the foundation block and above the frame and the anvil, you have this elastic pad. Okay. So I have considered this both separately. So basically, you can write like this. You can call this as a C1. You can call this as a K1. You can call this as a K2. You can call this as a C2. You can call this as a M1. You can call this as a M2. Now I have, and you can call this as a F. So now I have a parameter M1, M2, K1, K2, C1, and C2. Now you have to do the analysis. Now I am not interested in doing the analysis over here because for that, first of all, you have to understand the different methods. That is Newton method, Alemberts principle. That is another part. But now, tell me, have you understand this? Have you understand this concept of mathematical modeling? Yes. Okay. Now step number two. Now step number two. Now I come to the step number two. What is step number two? Now you have done a mathematical modeling. 1 second, guys. Just 1 second. Hello. Okay. Am I audible now? Okay. So first of all, we have understand a mathematical modeling. Now derivation of governing equation. Now derivations of governing equation means what? Now let us say you have this. Let us say m1, m2, c2, k2, k1, and c1. Now you what you do? You have to derive the equation of motion. Now what is the equation of basic equation of motion? Mx double dot plus cx dot plus kx is equal to f. This is a basic equation of motion. Now, for single degree of freedom system, you will get one equation. Similarly, for this equation, okay, for this 2 degrees of freedom system, you will get a two equation. For example, m1 x1 double dot plus c1 x1 dot plus k1 into x1 is equal to f, and maybe another equation m2 x2 double dot plus c2 x2 dot plus k2 x2 is equal to f. So I am getting a two equations. So basically, it is not that these equations are correct, what I have written. But the point of understanding is that the equation will be always in terms of m, c, k, and depending upon the parameters, there is x1 and x2. Okay. So basically, there are a lot of methods. So guys, first of all, derivation of a governing equation means what? You have to derive the equation of motion, right? And to derive the equation of motion, what is the first step? The first step you have to draw the FBD. Okay. Now already we have understand in the last lecture regarding the inertia forces and spin force. How do we draw the FBD for the okay? How to draw the free body diagram? I have explained you for the mass, spring, and the damper. Okay. You can watch the latest last video also. But again, while solving a problem, I will also explain how to draw the FBD. So first step is draw the FBD, then apply some method. Let us say Newton method. Let us say you are applying some Alemberts principle, and then finally you are getting the equation of motion. This derivation of governing equation is nothing but to calculate the equation of motion. Is it clear? Okay. So there are a lot of equations. A law of conservation of energy. Law of conservation of energy means what? Energy can neither be created nor be destroyed. Okay. It just can be converted into one form to another form. So there are a lot of these things are there. Okay. Then next is solution of governing equation. Now once you got equation, let us say you have two equations m1 x1 dot double dot plus c1 x1 dot plus k1 x1 is equal to f. Similarly, m2 x2 double dot plus c2 x2 dot plus k2 x2 is equal to f. Now we have equation number one, equation. Now the third step is to find out the solution of this governing equation. What is solution of the governing equation is what? Now basically you can apply some Newton method. You can apply some again D'Alemberts principle. Okay, so you can directly find out the Newton's method and D'Alemberts principle. Means what? Using Newton and D'Alemberts principle, and third is energy method. You can find out all the parameters. All the parameters means what? From this you can find out omega and natural frequency. Okay, you can find out Fn, that is natural frequency in hertz, right? So you can also find out the time period. So whatever is required, you can find out this by using this equation. Okay. Now this is now these methods are easy for a single degree of freedom system, but if you go for a multi degree of freedom system, then there are another method like Laplace transform method is there, Laplace method is there, then the matrix method is there. Okay, then there are some numerical methods are there, numerical methods are there. There are some Holger's method. Okay, so lot of Rayleigh's method is there. These are all name of the standard Rayleigh's. Okay, so these all methods basically you will study in the next year. There is a mechanical vibration where you have to study the advanced vibration. There is a multi-degree of vibration system, right? Okay, but here in your dynamics of machinery, we are interested only in a single degree of freedom system. So we are not understanding or we are not studying all these. You can say. Uh, Methods. But the most common thing you will find is what? All the methods are related to the mathematics. Okay. And last one is interpretation of result. Means what? The solution of governing equations. Now basically what you get from this equation, the solution of governing equation gives you the what? Displacement, velocity, acceleration, natural frequency, time period. So lot of values you will get from the solution of governing equation. Okay. Now you have to interpret this result. You have to interpret this result. Interpret results means what? Whether these results are correct or whether these results are suitable for your design, whatever machine you are designing. Okay, whether it will give you a less vibrations, whether it will reach the steady state at earliest as possible. The settling time is very less. Okay, all this is nothing but the interpretation of the result. Okay, so I hope you have understand this. So I declare that the basic concepts of mechanical vibration is over. Okay. So now I will move on to the next part. Please message me. Have you understand all the concepts or not? Have you understand all the concepts or not? Please message me. So from module, yeah. So now in module number one, in module number three, we have finished the part 1.1. Now we will start with the part 1.2, and then 1.3 is nothing but the problems. Okay. So let us move on. Now your module, first of all, understand the statement. Your module is free undamped single degree of freedom vibrating system. Okay. Now guys, I have already explained what is free. What do you mean by undamped and what do you mean by single degree of freedom system? Okay. Anybody? What do you mean by free vibration? What do you mean by free vibration? Anybody? Just we'll split it and define. Anybody? What do you mean by the free vibration? What do you mean by the free vibration?
No external force.
Yeah, no external force. We are just
No external force.
not. You can't say that there is no external force. You should say that
Without damping.
we are just applying. We are just giving a small. You can say initial displacement. Okay. We are not applying a continuous force. That is called the free vibration. And what do you mean by the undamped? What do you mean by the undamped? Anybody? What do you mean
No
by
Without any
resistant force to
there
the
is,
vibrating
there is,
body.
there is no external damping. Okay, a resistance or internal resistance is considered as a undamped only because they are very negligible. But no artificial damper means was undamped. And what do you mean by the single degree of freedom system? Only one coordinate x or theta is sufficient to specify the motion of the system. Now, when you combine this all the three statements, it is called as a free undamped single degree of freedom vibration. Means what? A system where there is no resistance to the motion externally and it vibrates freely after giving an initial displacement on its own due to the internal elastic properties, and only one coordinate is sufficient to define the motion. It is called the free undamped single degree of freedom system. And so your module number four will be free damped single degree of freedom system. Right now, see how they have split it. First time we understand all the basic concepts I have explained you. Now we'll understand the free undamped, and then we'll understand the free damped. So module number three is free undamped. Okay. So you understand already. Model number 4 is, this is 3. Model number 4 is free damp, and model number 5 is force vibration. In force vibration, it is not like undamped or damped, because force vibration, it is always a damped vibration. Okay, why I will explain later. Chalo. Now, first of all, if the initial disturbance is given to the system, then the system vibrates on its own due to the interelastic forces. This I have already explained, just I am revising. Okay, such type of vibrations are called as the free vibrations. If there is no external artificial resistance or damping to the above vibration, then such vibrations are called as undamped free vibration. Means what? There is a system, let us say it's a spring mass system, M. Okay, X is the only coordinate K. Now you are giving the initial displacement X and there is no C. There is no C. You can see there is no damper. The C will not come. So guys, just can you tell me what will be the equation of motion in this case? The basic equation of motion will be mx dot plus cx dot plus kx is equal to f. But in undamped free vibration, your cx dot will be 0 and f will be 0 because you are not continuing the force and we don't have external. So it becomes mx double dot plus kx is equal to 0. So this is nothing but equation of motion which we will be deriving for undamped free vibration. Okay. I hope you have understand this. Okay. If I take only a damped free vibration, then equation of motion will become mx double dot plus cx dot plus kx is equal to 0. So cx f will be again 0 because again it's a free vibration. But when I take a force vibration, this equation becomes mx double dot plus cx dot plus kx is equal to f sine omega t because we are applying a harmonic excitation. So how to derive this equation of motion, we will see one by one. So I hope it is clear to you. Okay. So such vibrations called the free vibration. So when omega is equal to omega n, what will happen? This system, this condition is called the resonance. Resonance means what?
Resonance.
Resonance. If I draw amplitude, let us say capital X, amplitude means what? Maximum displacement. The graph will be like this. Initially it is very high, then maybe it will decrease, maybe again it will decrease, maybe again it will increase, and will go to the infinity. And at some point of time, if the system will fail. So if you see the graph is with the increasing amplitude, right? This is happen at the resonance. But we are interested in what as an engineer we are interested in to avoid the resonance. Okay. So omega is the natural frequency of the body. Omega is the frequency of action. So amplitude of vibrations become excessively large, and this condition of state is called as a resonance. Resonance is dangerous as it leads to the failure of the machine component because the graph goes to the infinity. This means what? The system becomes unstable. Okay, so this is all this PPT I'll be giving you. Don't worry. Okay, so to avoid resonance, so now as an engineer, what you have to do? You have to avoid this resonance. So to avoid the resonance, but how will you avoid the resonance? To avoid the resonance, the designer should know the natural frequency of a machine parts subjected to the external force. So what you have to do? Basically, you have to do the analysis of omega n and omega. Means what? You should try to find out what is the frequency of external excitation force acting on the vibrating body and what is the natural frequency you have to fix. What will be the natural frequency you have to design so that this condition will never occur. That is, omega should not be equal to omega n. And not only this, but your settling time should be very, very less. What do you mean by the settling time? Let us say this is a graph of P, this is a graph of X. Okay. Let us say this is some desired line or output line. Let us say this is okay. Now, as I said that this is nothing but a transient state and this is nothing but a steady state. Okay, steady state means what? The system reaches to the steady state condition. Transient means what? Output behaves with respect to time. Okay. Now, the time taken by the system to start from zero and reach the steady state is called as the TS, that is settling time. Now this settling time should be as low as possible. When settling time तुमचा जेवढा कमी असेल तेवढी सिस्टीम तुमची steady state conditionला येणार आहे. Because each and every system will always pass through this transient system and it will reach the steady state. फक्त काय की तुमचा ट्रान्झिएंट झिरो झाला पाहिजे, इव्हेंच्युअली डाय आउट झाला पाहिजे आणि तुम्ही स्टेडी स्टेटला पोहोचला पाहिजे. मग स्टेडी स्टेटला पोहोचण्यासाठी किती वेळ लागला तो कमीत कमी असला पाहिजे. दॅट इज कॉल्ड एज अ सेटलिंग टाइम. I hope. And such a system which always passes through the transient successfully and reaches the steady state, it is called as a stable system. I hope you have understood this. Okay, means what? As an engineer, you have to design a stable system. Okay. Now, now you have understand that first thing is that you have to find out the omega. Okay. Now it is not in your hand that you should you are not able to always design the omega because you are not always able to fix the omega because sometimes omega. Let us take an example of a wind velocity, earthquake, or let us take an example of a tsunami. You can take an example of a natural calamities, or obviously you can take an example of a road condition because when you are driving an automobile, the external excitation force is coming from the rough road, that is omega, from the downward direction. That is also not in your hand. That is in the hand of the government, right? So basically, in that case, you can just design the omega n. So that is why this natural frequency omega n is very very important. As I earlier said that there are a lot of omega like omega, omega n, omega d, omega p, omega c. Okay, so you'll see one by this. We'll cover all these frequencies which are very very important, but all are frequencies. So you have to understand omega and omega n. Okay, so natural frequency means what? Omega n is nothing but a frequency of free vibration basically. Omega n is called the frequency of free vibration. Okay, means what? Whenever the system is vibrating under the you can say sorry, whenever you give an initial displacement and the system vibrates on its own, it is called the free vibration, and the corresponding frequency will be the natural frequency omega n. So frequency of free vibration is called the natural frequency. So natural frequency depends upon the geometrical parameters and mass properties of the property. It depends upon the geometrical parameters and mass properties of the okay. It is independent of the forces acting on the body of the system. Very very important two statements to start your analysis. The natural frequency जी काही तुम्ही डिझाईन करणार आहे त्याच्यावरती तुमच्या forces acting on the body of the system does not have any effect. Doesn't matter what are the forces acting. The force is variable force. Absolutely doesn't matter. Okay, it basically depends upon the mass and the geometrical parameters. Okay, very very important condition. Okay, mathematically first of all need to find the equations of motion of a particular vibrating. As I said that means what you have to do the mathematical modeling and then you have to find out the equation of motion means what governing equation. Okay, so why this? Because unless and until you do the mathematical modeling, do calculate the equation of motion, you cannot find out the omega, that is a natural frequency. Okay, and again, as I said that in this model we are considering a simple harmonic motion. That is why I have already derived the fundamental equation for the simple harmonic motion. Means what? This F external excitation force is simple harmonic motion I am considering. So x double dot plus omega n square x is equal to 0. This is nothing but a fundamental equation of simple harmonic motion which I have already derived in the first lecture or maybe second lecture. Okay. So natural frequency of a system can be determined by equilibrium method, energy method, and Rayleigh's method. Okay. Now, guys, I am interested in the single degree of freedom system. Okay, I am interested only in single degree of freedom system. That is why these three methods are sufficient. Equilibrium method means what? Alemberts principle or Newton's method. Okay. Now try to understand that Newton method and Alemberts principle are one and the same. ते दोघंही सेमच आहेत फक्त ते जरा वेगवेगळं सांगतात. This Newton is saying that eat by left hand, Alemberts is saying that eat by right hand. शेवटी जेवण तुमच्या पोटातच जाणार आहे, अन्न तुमच्या पोटातच जाणार आहे. समजतंय? तुम्ही कुठल्याही हाताने जेवू शकता. फक्त तुम्हाला कुठल्या हाताने सोपं पडतंय, डाव्या का उजव्या हाताने? ते किंवा तुम्हाला कुठल्या हाताने जेवायला आवडतंय, डाव्या का उजव्या हाताने? Okay, so basically it is always easy and it is we are familiar to eat food with the help of a right hand. So basically D'Alembert's principle is a right hand and Newton method is a left hand. So what I mean to say is that D'Alembert's principle is very very easy, but Newton method is also not difficult. Okay, so normally they don't state which method to use. They just give you the problem and say find out the natural frequency omega. It's your choice, but you should know all the methods. Okay, so tell me which hand you will use, right hand or left hand? Before I go to the slide, give me the answer. Which hand you will use, left hand or right hand? Right hand. ओके, बरं. मग मी तुम्हाला अजून असं सांगितलं की ओके जर कोणीतरी तुम्हाला अन्न भरवतंय तर ते अजून सोपं जाईल. इट विल बी व्हेरी इझी फॉर यू. समवन इज फीडिंग यू. Yes, you are saying that right hand is okay, sir, but I am saying that let us say I am feeding you, I am or someone, anyone, your mother, your father, someone is feeding you. So it will be more easy. Yes or no? Yes. Let us speak. Yes. So
Yes,
I
sir.
have a next method called the energy method. This is more and more easy as compared to the D11%. Okay. So I think this energy method is also very easy. But I will teach you all the methods. It's your choice whether to eat by left hand, by right hand, or whether to eat with by feeding someone. Okay. So first of all, let us start with the methods. D'Alembert's principle. Okay. Now, what is D'Alembert's principle? Now, basically, you know that whenever the let us say there is a mass, okay, and if the masses are accelerating means what? Acceleration x double dot. The inertia force will always act equal and opposite to this accelerating force. Inertia force is always equal and opposite to the accelerating forces. Okay. Now, what does this D'Alembert say? I have already explained in the model number 2. Once again, look. A body or a system which is not in a static equilibrium condition due to the acceleration means what? Let us say this is a mass m. Let us say I am applying a force F. So let us say x is a displacement, x dot is the velocity, x double dot. Now due to the acceleration, mass m, let us say, has displaced to the new position. Okay. Now this is nothing but a static condition. This is nothing but a dynamic condition. Now the inertia force, let us say Fi is nothing but inertia force. This inertia force Fi will act equal and opposite. Means what? It will try to bring this mass to its original position. Okay. So this is the statement of the D'Alembert's principle. A body or a system which is not in a static equilibrium condition due to the acceleration can be brought back to the static equilibrium by introducing an inertia force to it. Normally he says introducing, but obviously the inertia force will get get into the action. Okay. Inertia force is always equal to the mass of now Newton's means what? Inertia force is nothing but m into a, that is m into h double dot, and inertia torque I is T is equal to I into theta double dot for torsional system or linear system. Okay. I hope it is clear. So it is always equal to the mass and acceleration and is always opposite to the acceleration. Means what? Inner F is equal to m into a. This is nothing but the accelerating force. Then Fi is nothing but a minus ma. Very simple, right? That is minus mx double dot. So inertia force is always opposite and equal to that of the acceleration. Clear? Okay. Now D'Alembert's principle says that what is the statement? While solving a problem, summation of inertia forces plus external forces is equal to zero. If the system is a torsional system, summation of inertia torque plus external torque is equal to zero. समझ लें? Okay. Above principle is used to develop the equation of motion for any vibratory system and determine the natural frequency. Means what? By using this principle, first of all, find out mx double dot plus cx dot plus kx is equal to 0. But in this case, your cx dot is equal to 0 because we are considering only a free undamped. So I'm getting mx double dot plus kx is equal to 0. Then find out omega n. So omega n something you will get. Now आता आपल्याला derive करायचं की omega n काय मिळणार आहे. I hope you have understand this. Okay. So first of all, we are trying to eat by right hand because it is very easy. Okay. And then we will understand by the left hand. Then we will ask someone to feed us. Okay. So first of all, consider the spring mass system. Okay. Consider the spring mass system constrained to move along the axis of the spring. Now first of all, try to understand that this is a simple spring, right? This is a simple spring. Simple spring means what? A spring in an unstrained position. Spring in an unstrained position means what? There is no load on the spring. या स्प्रिंगला तुम्ही कुठलाही लोड लावलेला म्हणजे तुमची स्प्रिंग इलॉंगेटही झालेली नाहीये. म्हणजेच काय? त्या स्प्रिंगची जी लेंथ असेल ती ओरिजिनल लेंथ असेल. Let us say it is a original length. Let us say LF. LF is nothing but the original length of the spring. Okay. Now let us say that let m is the mass suspended from the vertical spring. Let us say that I am suspending a mass or I am connecting a mass to the spring a vertically downward direction. So now this is called the spring in a strained position. Now what will happen? This mass will move downward. Why this mass will move downward? This mass will move downward because of the weight of the mass, that is mg Newton. Because of the mg, what will happen? Del. What is del? Del is nothing but a deflection. What is deflection? Deflection is nothing but a displacement of the spring. Now this displacement del is directly proportional to mg. What is mg? mg is nothing but a force which is acting in a downward direction. I said already that. I said number of times that the force required to cause a unit displacement in the spring is always directly proportional. So what I mean to say is that जेव्हा तुम्ही मास m ला मास m जेव्हा तुम्ही कनेक्ट करता स्प्रिंगला तुमच्या स्प्रिंग मध्ये किती डिफ्लेक्शन येणार डेल and this del is called as a static deflection. This del is called as static deflection. Means what? This system is not a dynamic system. This system is a static system only. अजूनपर्यंत मी ह्या सिस्टीमवरती एक्सटर्नल फोर्स अप्लाय केलेला नाहीये. अनलेस अँड अंटिल आय अप्लाय एक्सटर्नल फोर्स, द सिस्टम विल नॉट व्हायब्रेट. सो दॅट इज वाय हे सुरुवातीला होत आहे. सुरुवातीला मीन्स व्हॉट, तुमचा मास इथे येणार आहे आणि मास तुमचा काय होणार, सेटल होणार आहे. सेटल होणार आहे म्हणजे तुम्ही सपोज एक स्प्रिंग घेतला, तुम्ही मास कनेक्ट केलात, that mass will move in a downward direction, and after some time that mass will also settle and that spring will also settle. Means there will be no any oscillation, there will be no any vibration inside the spring and inside the mass. Is it correct? So that is why this position which you can see in your front of the you can say slide in front of you is nothing but a static equilibrium condition, and del is called the static. So basically try to understand this. X is nothing but a displacement. It is a dynamic displacement, not a static. It is a dynamic deflection. And this del is nothing but a static deflection. Okay, because there is no any vibration. फक्त त्याच्या वजनामुळे तो खाली आलाय. Okay. Now, how will you draw the FBD? First of all, FBD means what? Let us say mass M. Now let us say how will this mg act? Mg will act downward. Okay.
Downward.
Now downward. Now tell me what will be the spring force? What is the spring force? Spring force F is equal to K into X. But in this case, what is X? X is nothing but a K into del. So K into del. Now what is the spring force? Spring force always acts opposite to the displacement. Now where is the displacement of the mass? Displacement of the mass X is downward. So where will the spring force act? Upward. Okay. So that is why K into delta spring force will be acting upward and mg will be acting downward. And now I am getting a free body diagram. So from this, what you get? From this, you understand that K into delta is equal to M into G, right? Because एक upward तुम्ही positive घ्या, downward तुम्ही negative घ्या. So it will become K into delta minus mg is equal to 0 is equal to mg, whatever you can write. Okay. So we'll take upward positive and negative, right? So K is the stiffness of the spring Newton per meter. There is a deflection of the spring due to the weight, which is called the static deflection. Okay. Now from the FBD of the figure, I am getting mg is equal to K into delta, and this is my equation number 1. What I'm doing, I have taken a simple spring mass system as a physical system. I have done a mathematical model. Now in this case, no need to go for a mathematical model because already the system in the M and K, okay, parameters. Now I have drawn a FBD. I have got equation. Now I will derive the equation of motion, and then I will find out the omega n, and from omega n I will get the Fn, that is the natural frequency in the hertz. Okay. Now what is next step? Now let us vibrate this system. Vibrate means what? Let us say that x is the initial displacement given to the mass m from the position. Now I am interested only in the free vibration, so I am just giving an initial displacement. And if I am giving an initial displacement, again the system is undamped, so there is no any shift. But due to the air resistance and due to the internal elastic properties, the system will come to the steady state. Okay. So let us say that x is the displacement. म्हणजे मी या mass m ला x हे downward displacement देतो. Now tell me what will happen. Anybody? What will happen? So I have a less time to draw the figure. So I have taken a ready-made figure. So what will happen? See. So initially this was the initial position. This was the initial position del. This mass was deflected by del. Now let us say that we are giving a small displacement x. So let us say that x is a small displacement in a downward direction. Now, if x is the small displacement in the downward direction, what will be the total deflection of the spring? Anybody? The initial displacement was delta. Yeah. So x plus delta will be the total deflection of the spring. So obviously you have to consider the static deflection, but you can neglect the delta. Why? That I will explain you later on. Okay. Okay. Now let us draw the FBD. Now I hope you have understand this. Okay. Now let us draw the FBD. Let us say M. Where is the displacement of the mass? X. So where will be the acceleration and velocity? Downward. Okay. Now, first of all, locate the inertia force. Now, inertia force always acts opposite to the displacement. What is inertia force? M into H double dot. Opposite to the X. Then spring force. What will be the spring force? Anybody spring force क्या है? K into X plus delta. Delta opposite. Okay. And gravitational force mg downward. Okay. Now you have this free body diagram in front of you. Okay. Now let us draw the equation of motion. Now tell me, have you understand how to draw this free body diagram?
Yes.
Have you understand how I draw this free body? Always remember that spring force, inertia force are always opposite to the displacement. So always show displacement x dot in the downward direction. Okay. And एक लक्षात ठेवा, velocity and acceleration will be always in the direction of the displacement. So this is nothing but a x dot, x double dot. Okay. चलो. So anybody, according to the I'll apply the D'Alembert principle, summation of inertia force per external force. Now tell me, what is inertia forces? What is inertia force? So let's
mx double dot.
yeah, mx double dot. Okay. Then plus what is the external force? K into external force काय याच्यामध्ये?
X plus del.
X plus delta. And what is this? Sorry. What is this mg?
mg.
Minus or plus? Minus. Okay. We'll
Minus.
minus downward is equal to 0. He झालं माझं equation of motion, right? कळलं मग equation of motion is mx double dot plus k into x plus del minus mg is equal to 0. Now, hey, open up the bracket. So mx double dot plus kx plus del k del minus mg is equal to 0. But you know that k delta is equal to mg. K delta is equal to mg, बरोबर ना? मग तुम्ही काय करू शकता? या k delta is equal to mg असेल तर mg च्या ऐवजी k del पुट करा, म्हणजे k del कॅन्सल झालं. म्हणजे याचा अर्थ काय झाला? जेव्हा आपण व्हायब्रेशन अनालिसिस करतो तेव्हा डेल हा आपण कन्सिडर करत नाही किंवा mg हा आपण कन्सिडर करत नाही, म्हणजे वेट ऑफ द मास आपण कन्सिडर करत नाही. द मास ऑफ द वेट mg will be always acting in a downward direction, but this mg gets cancelled with the k into delta because mg is equal to k into delta, and that is why whenever I'll be doing a vibration analysis, I'll be always neglecting this mg because this mg gets cancelled with this k into delta. Have you understand why in vibration analysis we are neglecting the weight, the force due to the gravitational g? Clear? कारण तो के डेल्टा सोबत कॅन्सलच होणार आहे ना, म्हणून आपण तो पुढे घ्यायची गरजच नाही, वेळ कशाला काढायचा. ओके. सो फायनल इक्वेशन काय मिळालं? mx डबल डॉट k into 0. सो व्हॉट इज हा डिवाइड करा. सो इक्वेशन मिळालं x डबल डॉट प्लस k अपॉन m into x is equal to 0. ओके. सो लेट अस से दिस इज इक्वेशन नंबर 1. सो व्हॉट इज द फंडामेंटल इक्वेशन ऑफ मोशन? Comparing with the fundamental equation of motion, compare this with the simple harmonic. What is that comparing equation? X double dot plus omega n square into x. आणि आपलं इक्वेशन काय? आपलं इक्वेशन काय? x double dot plus k upon m into x is equal to 0. आता हे दोन्ही तुमचे इक्वेशन आणि फंडामेंटल इक्वेशन सोबत कंपेअर करा. तुम्हाला काय मिळणार? ओमेगा n square is equal to k upon n. So omega is equal to k upon n. So what is the equation? Omega is equal to square root of k upon n. Means what? The natural frequency depends upon only the two parameters, that is the geometrical parameter k and the mass property, that is the m. Okay. Is it clear? So what is Fn? You know that Fn is equal to omega n upon 2 pi. So Fn is equal to 1 upon 2 pi into square root of k upon n. Okay. Now guys, you apply any method. You apply Newton method, you apply energy method, you apply D'Alembert principle. Finally, you will get same answer. Now tell me, have you understand how I have used D'Alembert's principle? काय doubt आहे का सांगा मला तुम्हाला याच्यामध्ये. Okay. Now I will just modify the equation. Sometimes it is very helpful to solve. Now we know that mg is equal to k into delta. So k upon m is equal to g upon delta. So you can write Fn is equal to 1 upon 2 pi. Means what? That is equal to 1 upon 2 pi square root of k upon m, and k upon m is equal to g upon del. So sometimes in your problem, maybe k is not given, m is not given, but del is given and g is 9.81. You can find out Fn, and from Fn you can find out omega, and from omega, let us say omega n माहिती आहे, m माहिती आहे, तर तुम्ही k find करू शकता. Okay. So this equation is sometimes helpful for you. Now time period. Now what is time period? Time period is nothing but the reciprocal of frequency. So Tp is equal to 1 upon omega n. So time period is equal to 2 pi into mk into s. Okay. Is it clear? Is it clear or not? Okay.
Yes, sir.
Okay. आता मी फक्त तुम्हाला 2 मिनिटात न्यूटन मेथड सांगतो and then we'll stop, because Newton method is very simple and it will be you can say based on the D'Alembert's principle. Now consider the simple spin mass system as shown in the figure. Okay. Final output will be same, a simple spin mass system. Okay. Now guys, try to understand that I am not considering this k delta is equal to mgy, because I have already explained you and they get cancelled. Okay. So I will directly consider the dynamic system. So consider a simple spin mass system. Let x be the small displacement given to the mass n. So x is the small displacement given to the mass n. Okay. Now consider the FBD of mass n. Now, first of all, how will you draw the FBD of mass? And let us say this is n. Okay, n x dot and x double dot. And what is the spring force? K into x. Okay,
Yes.
don't consider x plus delta because it is obviously neglected. Na? So here in Newton's method, we do not consider the inertia force. Inertia force is considered into the where? Alemberts principle. Okay, I hope it is clear to you. So this is your FBD. Very simple. In the FBD, you don't have an inertia force. Okay. Now, what is according to the Newton's law? Summation of F is equal to ma. Okay. Now summation of F is equal to ma. Sign convention. Taking upward negative and see here the sign convention is very important in Newton. Okay. So taking upward negative and downward positive. You can take vice versa also, my dear students. Okay. So upward negative here. So what is F? What is F? F is nothing but the external force. What is external force? Kx. Positive or negative? Negative is equal to m into a. M आहे तसा constant. Now x double dot. Acceleration means what? X double dot. X double dot is downward, so positive. Okay. तुम्ही असेही लिहू शकता. Kx is equal to minus mx double dot. You can write as it whatever you want, but sign convention is very easy. Okay. Now सो परत तेच होणार आहे जर तुम्ही इक्विलिब्रियम साठी इट शुड बी इक्वल टू 0 सो mx डबल डॉट प्लस kx इज इक्वल टू 0 राइट सो x डबल डॉट प्लस k अपॉन mx इज इक्वल टू 0 इक्वेशन नंबर 2 कंपेयर विथ द सिंपल हार्मोनिक मोशन तुम्हाला काय मिळणार ओमेगा एन स्क्वेअर इज इक्वल टू सो एंड सो एंड fn इज इक्वल टू 1 अपॉन 2 ओके सो एनर्जी मेथड आई विल एक्सप्लेन